All right, hello Math 2 people. Let's get this video off a little bit. Sorry for the delay, it took a little bit longer to get online than I thought with sort of the 3 p.m. start time. My apologies. Okay, we're on now to section 9.5. That's going to cover two new sort of skills here. And the reason we started with tangent sort of last week is we really needed to drill in the idea of what do we mean by opposite and adjacent. So relative to an angle, which side's basically on the opposite, it's not touching. Now, all of these are right triangles. I can't stress that enough. Everything we're doing is a right triangle. So I even forgot to mark that in here. Let's draw that in real quick. In a right triangle, if I take one of the two angles that's not the right angle, what side's opposite, what side's adjacent? I've matched the color here. So we can see if I've got this angle theta down here, the green side is going to be my opposite, the red is my adjacent. I'm basically talking about the two legs in this case, okay? If we have that, we can now work with two new trig functions. First one is what we call sine, S-I-N-E. Sounds just like the word like stop sign, S-I-G-N, but it's another ratio, a trigonometric ratio. S-I-N-E, we're going to write it as S-I-N, and then with the theta, so with the last one, we would say tangent of theta. This symbol right here, I'm going to read as sine of theta. It's not sin, it's sine of theta, but we continue to use those three-letter abbreviations. Now, you'll get sort of a toolkit thing on this here in a second. It's a ratio of your opposite side and the hypotenuse. As a reminder, the hypotenuse is the side opposite the right angle. So if I go back to this guy right here, this black side right here, that's my hypotenuse because it's opposite the 90. It's not touching that guy. In a right triangle too, if we know which ones are the legs, the hypotenuse is basically the third one, right? It doesn't touch the 90-degree angle. The second one we have is the cosine, so C-O-S-I-N-E. The three-letter abbreviation we use for that is C-O-S. So if you see C-O-S and then parentheses theta or whatever angle you have, we're building off all the stuff from last week, that reads as cosine of theta. You don't say cos or cos or anything. It's just you say cosine, but you're going to use those three letters. It's a ratio of the adjacent side and the hypotenuse. So tangent was a ratio between the opposite and adjacent, which is why we need to know those two relationships. Sine is opposite and hypotenuse. Cosine is adjacent and hypotenuse. Let me put this all together, okay? So if I've got this triangle here, we've got a 90-degree angle in one corner, and I've got sort of this theta here. My sine of theta is whatever my opposite side is, the green one in this case, divided by the hypotenuse in black. Cosine of theta is the adjacent side divided by the hypotenuse. So everything that you know about tangent and how to like set those problems up, great. It's the same process for these. It just changes the ratio and then which trig function we use with it. Sine and cosine are our two new ones, which are SIN and then COS for those three-letter abbreviations. All right. Now, you're going to at some point hear somebody say this phrase here, this SOHCAHTOA. That's SOHCAHTOA. Again, I heard this back in high school. This is like, for a lot of people, it gets to that like mitochondria is the powerhouse of the cell. Like, I remember this after high school phrase, SOHCAHTOA. What it stands for, and this is going to be a little wild, basically stacked all these words vertically. Sine is your opposite over hypotenuse. That's the SOH. So when you think SOH, sine of an angle is opposite over hypotenuse. Cosine of an angle, is the adjacent side over the hypotenuse. TOA, the one that we did last week, tangent of an angle is the opposite over the adjacent. So people get pretty good at remembering this, or even like write it at the start of a test to help them follow through. I like to write it a slightly different way. I do my SOHCAHTOA where I'm stacking the opposite and hypotenuse for sine. I'm stacking adjacent and hypotenuse for cosine. And I'm stacking opposite over adjacent for tangent to show that these are fractions. Okay? Again, use this. This is a pretty common mnemonic device, something that you can just like help your brain remember these pieces. If you already just know these or you can commit this whole thing to memory, great. You don't need to worry about this. But there it is if you want it. Page 548 shows another sort of visualization of this idea of like, if I'm talking about this angle for sine, if we're talking about A, It's the opposite leg, which is green here, over the hypotenuse, which is red. Cosine is the adjacent leg, which is the blue one, over hypotenuse, which is still red. Tangent in this case of A would be the opposite over adjacent, or green over blue, if we were messing with that. By the end of this, we will kind of mix all three. So let's actually put them to use here a little bit. The same sort of style stuff that we were doing in the past, we're doing again here. We're going to find 4 ratios here. Sine of S, sine of R, cos of S, cos of R. We're on page 548, example 1. And kind of even what I saw with some of the quizzes coming in, and I'll get those graded here pretty soon. Oops, come on. You're going to let me? Nope, I got to undo this real quick. Hold on. We're just going to basically modify these pieces and substitute the numbers, right? It says a fraction and a decimal rounded to 4 places. You just type in a calculator. I'm not super concerned about that. So for space, I'm not going to do the decimal portion. Let's start off with sine of S. What is the opposite side from angle S? Well, angle S is this top right corner right here. The leg that is not touching it is 63. So I'm going to replace this word opposite here with 63. My hypotenuse is the biggest side of my right triangle, and it's opposite of my 90. That's going to be, in this case, 65. Now, what's this? Can we reduce this at all? Not really see much. That guy can be divided by 3. This guy can't. That guy can't be divided by 5. There's your sine ratio. Sine of S is 63 over 65. Right? There's not too much we can really do with it. Right, let me think. This is just the same. I'm just double checking here that, yeah, 13. That's not going to work with the 63. Yeah, nothing we can do. 63 65ths doesn't reduce. Okay, that's sine of S. What is sine of R going to be? I'm going to just copy all this guy down. Sine of R. Oops, I should capitalize that because it is an angle. Relative to where angle R is now, my opposite side has changed. My opposite side is now 16. So I'm going to change that 63 here that I copied into a 16. That's my opposite side. My hypotenuse is still 65. So that guy's not going to change. Can't really reduce these guys too much either, right? 16, I can divide by 2, 4, 8, 16. I can't divide 65 by any of those, so it's done. That's all. Type into a calculator if you want to figure out those decimals. I'm not too worried about it. All right, now let's do cosine of S. Cosine is going to be my adjacent side. Let's turn this guy into red here. From side S, or sorry, angle S, my adjacent side, the one that's touching it, is the 16 right here. The hypotenuse, still 65. That hasn't changed the whole time, right? The hypotenuse, it doesn't really matter which of the other 2 angles you're talking about. It's always going to be the same value. So cosine of S is 16 over 65. Cosine of R, well, now that I'm at angle R, the adjacent side, the one that's next to it, is now 63. And the hypotenuse is still 65. Now, maybe you're noticing something here. Maybe you're noticing that, let me get my arrows in this case. I'll just draw it. You might realize that sine of S and cosine of R are the exact same fraction. And sine of R and cosine of S are the same fraction. That's actually a property. That's basically what we're going to kind of sort of cover in the next thing here. If I know that this angle is 90, how much do my other 2 have to add up to? They're going to add up to 90 degrees. Which means this property is kind of interesting. This is on page 548. It says sine and cosine of complementary angles. Complementary are angles that add to 90. If I have 180 degrees in a triangle, and one of them is a 90 degree because it's all right triangles, I have 90 left over. That means those 2 are complementary. All this is really showing you a fancy way of saying, if you know one angle, if I know one angle, and I know my sine ratio, that's the same as cosine of the other angle. It's what all this 90 stuff is saying here. If I know cosine of one of my angles, that's equal to sine of the other one. And it basically just flips all these pieces. Okay? Let's put it to work. Write sine 56 in terms of cosine. This is page 549, example 2. Well, I'm going to go ahead and draw this right triangle. Okay? Oops, goodness. I'm going to do a better triangle than that. Okay, here we go. Got a right triangle. We're going to call, in this case, this guy right top. I'm drawing a triangle with my top left angle is 56. I don't have my side lengths here, and that's not really what it's asking for. Okay? It's just saying, what would it be equal to? Well, if we go back to this piece right here, it's saying that sine of an angle is equal to cosine of 90 minus that same angle. And it wants me to write sine of that angle as cosine in terms of cosine, meaning I can now take this. I can do sine of 56 is going to equal cosine of, and what we just saw in that previous slide was 90 minus the current angle. Well, all right, let's clean that up a little bit. What's 90 minus 56 going to be? 90 minus 60 would be 30. We've taken away an extra 4. So what's that going to be? 34. Oops, I lost a parenthesis. Sine of 56 and cosine of 34 are the exact same thing. And let me try and go back to this triangle here and convince you. This other angle here has to be a 34. You can double check that math. 50 plus 30 is going to be 80. 6 plus 4 is 10. Add those together, you get 90 for those other two angles. Sine is relating the opposite over the hypotenuse. Well, the hypotenuse is always across from this right angle here. Oof, done a better than that. From the 56, the opposite is this side right here that I'm highlighting in blue. If I go to 34, what is that side now called? That becomes the adjacent side. Since both are divided by hypotenuse, sine's talking about the opposite, cosine's talking about the adjacent, but since we switch the angles, they're talking about the same literal side of the triangle, which is why this works. Okay, let's actually put it to use even a little further here, okay? Now, this is going to require a little bit of calculator stuff. Page 549, example 3. Find the values of x and y using sine and cosine. There's multiple ways to do this, but since it gives me 26, I'm going to stay with this. You could combine that previous skill, the 90 minus 26, and basically flip the way you do this and still get totally correct answers, okay? I'm going to start off with, let's finding x, right? It's the first one it asks for. From angle 26, x is my opposite side. And I have my hypotenuse right here, which is 14. So what I can do is I can write sine of 26, because it's always of an angle, just like last time, is equal to, my opposite side, which is x, and then divided by my adjacent, or sorry, the hypotenuse here, which is 14. So this is kind of probably looks, a little arrow instead of a line, that's fine. Sine of 26 equals my opposite, x, divided by 14, my hypotenuse. I'm asking you to solve for x. We're going to multiply both sides by 14. If you want to think about it as 14 over 1, that works. I'm trying to get x by itself. So really what I need to figure out is, what is 14 sine of 26? That's equal to x. Let's pull up a calculator. Oops, come on. The computer's going a little slow. You could still use that same Desmos calculator. I'm going to pull up the TI-80 version here. Just because that's kind of what I'm familiar with. If you do some stuff next year, you're going to see a lot of the same thing. This is on the previous link on the classroom. Do remember, we have to be in degrees. So I'm going to turn this into degrees right away. Otherwise, I might start getting some weird, funky answers. All right, now that we're in degrees, oops, verify, yep, still in degrees. I needed to do 14 times sine. It's 2 to the left of where the tangent button is. I'm going to type 26, close the parentheses, hit enter. Great. What's x? It's that value, 6.1372, we'll call it, if I'm rounding to 4 places. 6.1372. There you go. If I now need to find y, excuse me, I know angle 26 right here, okay? I found x, great. Oops, delete all this, come on. Okay. From angle 26, let's change the color, y is now the side that's right next to it, meaning it's adjacent, and 14 is still a hypotenuse. Well, this setup's going to look pretty darn similar to the one that we just did. Cosine of an angle, so in this case still 26, is going to equal the adjacent side, which is now y, divided by the hypotenuse, which is still 14. If you compare to the previous question, it's basically the same setup, except it changes which side we're looking for. That means the algebra is not really going to be any different. I'm still going to do 14 multiplied on both sides to cancel out this dividing by 14 and get y by itself. What do I need to literally type into the calculator to find y? 14 cos of 26 equals y. We're still in degrees already. That hasn't changed from the calculator. Let's do 14 cosine of 26. 12.5831. That's it. That's all we're doing. Nothing. It's the same skills that we just changed in our ratios. What did I just say that was? 12.5831. We could give you information about maybe an adjacent or opposite side and ask you to find the hypotenuse, which would put an x in the bottom. You solved problems like that last week with tangent. It's just identifying which tool do you need to use in this case here. Okay, now we're on page 549 and monitoring progress numbers 1 and 3 here. I'm going to work through a couple problems, all right? I'm going to go a little bit quicker with these. If we've got questions, please pop into office hours. Ask some questions about it. All right, I'm going to copy something from a previous slide real quick, though, just to make my life a little easier. Where is it? All right. So, we got this triangle here. Come on. First up, we're finding sine of D. So looking from angle D, what is my opposite side? The side, the leg that's not touching it, that's a 7. Hypotenuse is 25. I'm not going to worry about the rounding to 4 places. Right, you can type it in the calculator if you need to figure something out exactly like that. What do we have? 25 for this guy. There's sine of D. 7 over 25. Done. Can't do anything else with it. What's sine of F going to be? From angle F, the opposite side is now 24. The hypotenuse is still 25. So, sorry for that. Sine of F is 24/25. That's it. Can't reduce it. Type it in a calculator if you're real concerned about that. I'm not super worried. All right. Let's find cosine of D. Sounds like my little dog is making some noise, chewing on a bone in the background. I apologize. Cosine of D, so from angle D, the side that's adjacent to it, that's touching that leg, is now 24. So that's why we spent all that time last week hitting those ideas of which one's opposite, which one's adjacent, because those relationships are still the same. Hypotenuse still 25. And we see again, sine of F is the same as cosine of D, because we switched to that other angle. So the ratios are going to be the same, even though it uses a different trig function and different angle. So you might be able to reason out, oh goodness, what this next one here, what cosine of F is going to be. My adjacent side next to angle F is now the 7. Hypotenuse is still 25. And we see cosine of one angle, so cosine of F is the same as sine of the other angle. Sine of F is the same as cosine of the other angle. Great. Problem 2 is like a little mini quiz here asking you, write cosine 23 in terms of sine. Let's do it. Cos of 23 at this point is going to equal sine, oops, not sine, of 90 minus the 23. Clean that up. What's that going to actually equal, right? This is the idea that we're basically switching to the other angle. 90 minus 23, 90 minus 20 would be a 70. Take away 3 more. 67. Oh, I should put a degree somewhere. That's it. Cos of 23 is the same as sine of 67. All right, third problem, find the values of u and t using sine and cosine from this triangle. Okay. Is it going to let me? Let's drag one of these down. All right, let's start off by finding t. In this case, t is opposite of the 65, so I'm going to keep using sine here. Sine of 65 is going to be my opposite side, t, divided by 8. So in this case, change my opposite side to t, change my, I'm sorry, I said my hypotenuse is 8. What do I do to get t by itself? It's currently being divided by 8. Let's come along, let's multiply. Goodness. Both sides by 8. If I multiply both sides by 8, it's literally calculator time. 8 sine of 65 is t. So what's that going to be? 8 times sine of 65. We have 7.250 rounded to 5. So 7.2505. 7.2505. There you go. We're trying to find u. Let's do the same sort of thing, right? We basically copy the same information over. Let me. It's gonna be a little weird. Relative to the 65, u is the adjacent side, so I'm going to switch to cosine, still of an angle, is my adjacent side, which is u, divided by, oops, the hypotenuse, which is still 8. It's not dragging my 8 over. Come on. To get u by itself, we're going to do the same thing. We're going to multiply both sides by 8, just like last time. So what do I need to type in a calculator? I now have 8 cos of 65 is equal to u. Type it in, let's see what we get. 8 cos 65. 3.3809. What is that? 3.3809. There you go. There's sort of like a mini quiz. Not too bad, right? All right. What's gone? Oh, yeah. The check for this week to make certain that you're paying attention. Last week I gave sort of a silly phrase. This week I'm very excited for an album tomorrow from one of my favorite bands called Dance Gavin Dance. I'm going to ask you the name of the album. The name of the album is going to be, it's called Afterburner. So you're going to see a question. It's not going to even say this sort of thing. It's going to be like, which album is Mr. Klepak excited for tomorrow? And the answer I'm looking for is Afterburner. One word, Afterburner. There's going to be some other fake answers up there. If you're getting one of these quizzes wrong, guys, then either we're not watching the video or we're forgetting one simple thing. Like as soon as I say this, Afterburner, just write it down. When you get popped to do that quiz to like literally get credit for watching the video, like it's, you do it and you get it right, you get full 5 points for that assignment, right? It's the easiest sort of assignment you could really do, all right? Album is Afterburner by Dance Gavin Dance. You're just going to see album titles, not even the band necessarily. It's going to say, what album am I excited for? Afterburner is the one I'm looking for. Thank you for watching the video. All right, page 50, or 551, example 6. Let's put this guy to use. Okay, like building a little bit of context in here. There's probably gonna be a word problem on your next quiz there. Okay, skiing on a mountain with an altitude of 1,200 feet. I mean, sort of its height. The angle of depression. So if I were to like be looking forward, and then how much am I looking down? That's called an angle of depression. So from the horizon going down, what is that? It says it's 21. We see that that angle right here is this 21. Find the distance x you ski down the mountain to the nearest foot. So like what length are you actually skiing? Hi, Kona. Kona's trying to get on camera here. Let's see. You want to get on stream, Kona? Cones, what are you doing? There you go. See? Just trying to say hi. You want to do some math? She wants to go O-U-T-S-I-D-E, that's for sure. And also wants some D-I-N-N-E-R, a little spelling test for you there. Okay. All right, Tony, you got to let me finish, all right? Thank you. Let's set it up. From the perspective of 21, I have information about the opposite side. So if you do that SOHCAHTOA, which one references the opposite side? Well, sine is going to use my opposite side, and I'm trying to find the hypotenuse, so that's why I'm going to use it. I have information about the opposite side, and I want the hypotenuse. Which one relates opposite and hypotenuse? Sine. Opposite over hypotenuse. If I had information about the opposite and wanted the adjacent, I would use tangent, but not in this case. I have the opposite side. I want the hypotenuse. Let's set it up. Okay, thank you, Kona. I know. Just trying to move my arm off the mouse that I can't. Kona, you got to stop. Okay, you're messing me up. Yeah, this is how you can tell these things aren't edited, too. We do one take. We do it live, and that's what you get. All right, so let's set this up. Copy from the previous slide. I'm just going to borrow these things just so I don't have to retype them out. So, sine in this case, we've already determined y of 21 degrees is going to equal the opposite side divided by the hypotenuse. My opposite side is 1,200. It's at 1,200 feet. The hypotenuse we don't know. It's x. We're asking you to use this to solve for it. This is just like some of those problems last week where we had an x in the denominator. What are we going to do to solve for this guy? Come along, multiply both sides by x. It's going to cross cancel on the right side. My left side, I'm going to get x times sine of 21 is now equal to, 1,200. What do I do to get x by itself now? Well, if it's being multiplied by sine of 21, I'm going to come along and divide by sine of 21. I'm just going to write this guy out. And then this is where you now need a calculator. These guys are going to cancel the sine of 21, so I get x equals, I literally need to figure out what is 1,200 divided by sine of 21. That's my answer. That's my x value. So, what's that going to be? 1,200 divided by, and I'm just typing this all in one, 3,348, and I'll say 0.5137. 3348, 5137. Okay. 3348. We'll say actually 0.5 because it's at this point we're asking how far you skied. No one's really concerned about the 7 there. How far did you ski down the hill at a 21-degree angle? 3,348.5 feet. Make certain that you actually, if it's a question involving some context, you would actually go back and say, oh, so to the nearest foot. I didn't even check. So that 0.5 is going to bump this guy up. Final answer is going to be, like, let's say a sentence. 3,349 feet down the mountain. There you go. Give me that. Get your 4 for any contextual problems. Cool. All right. All right, kind of the last skill here. So we're getting near the end, and then we'll explain some of the homework for you and what your process for the week looks like. Here, this is page 552, example 7. I'm telling you that cosine of theta is 3/5. And I'm asking for sine of theta and tan of theta. This is a little bit different than you might have seen. So what I'm going to do for all of these style ones, draw me the triangle, please. It doesn't have to be to scale, but it makes all the difference in the world, okay? It has to be a right triangle because this is all right triangle trig. So I'm going to put in my right angle on my triangle. The book is going to maybe explain this a different way. Let's use Pythagorean. It's giving me cosine. So I'm going to call this angle right here theta. Really one of the two that is not my right angle, and I'm good to go. Cosine is a relationship between the adjacent side divided by hypotenuse. So if I have 3/5, 3 is my adjacent side. What side's next to my angle? 3. Well, let's find, that means my 5 is the hypotenuse. So here's what you now need to figure out. I need to figure out that opposite side. We also know you have to figure out the opposite side because sine is opposite over hypotenuse. We don't have the opposite. Tangent is opposite over adjacent. We need to find the opposite. I'm going to call this an x right now. You can pick whatever letter really you like. Let's do some Pythagorean for this guy. Be careful. This is something I saw in some of the quizzes too, is that in this case I have x squared because it's one of the legs. It's not always the hypotenuse, it's the unknown guy. Plus 3 squared equals 5 squared. If we clean this up, let's do a little bit of algebra here. This is going to be x squared plus a 9. Too big. 5 squared is going to be a 25. If I subtract that 9 from both sides, what's that going to give me? X squared is going to equal 16. So let's take a square root of both sides, get x by itself. X is going to equal now 4. We don't have to worry about the negative because it's the side length. Now, can we go back and tell me what sine of theta and tan of theta are? Well, sine theta, I'm just going to write these out rather than copy, is always my opposite side from the angle, which now we figured out is 4, divided by the hypotenuse, which is 5. Opposite over hypotenuse, that's it. I don't know what the angle specifically is, but that's the ratio. Tangent of theta from last week, is my opposite side, which is 4, over my adjacent side now, which is 3. Done. Okay, dogs are fighting in the background. I don't know if you can say, okay. Guys, can we calm it down? Come on, Obes, come here. Come here. Come here. Lay down. Lay down. Boy, Obi. Thank you, calm. Can you guys calm down for a moment? I was going to have treats nearby. Okay. That's the process, right? We give you 2 pieces of information. Draw me a triangle. Label the parts that you know based on the ratio. You got it. It's all about knowing those ratios and just different ways of using them. We're going to do some Pythagorean theorem, so what we started this unit with, to find our third side. That third side is going to give us enough information to find these last 2 trig functions, okay? And I marked that, guys. Oh, I forgot to mention, yeah, any of these turquoise ones here are sort of the toolkits for those. I'll upload these slides later. Let's try another one, okay? Given that sine of theta is 5/13, find cos theta and tan theta. Let me draw, again, just one of those triangles. It doesn't have to be perfect. It doesn't have to be to scale. I'm just going to draw a triangle to help me label some of these pieces, okay? Right, I can draw the same triangle every time. Mark where your 90 is. That's going to make a difference. I'm going to put theta just in this bottom right corner, but it doesn't matter. You can put it in the top left if you want. Depends on how you draw your triangle. Since we know sine theta, it's telling us it's 5/13. That means my opposite side, because it's opposite over hypotenuse, my opposite side is 5. Hypotenuse is 13. Find cosine and tan. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I have to find this adjacent side here. So I'm going to set x as my variable here, and then let's do a little bit of Pythagorean theorem to find what that's going to be. I'm going to have x squared, because it's one of the legs, plus 5 squared, because it's the other leg, is equal to 13 squared. All right, let's clean this algebra up. This is going to be x squared plus 25 equals 169. Subtract 25 from both sides. That's going to give me x squared now equals 144. Take a square root of both sides. Square root of 44 is going to give me 12. And these are nice, pretty Pythagorean triples. If we give you one that's not a Pythagorean triple, think about everything we talked about the previous weeks. It's fine. It's the same skills. We just got to put them all together. You can leave a square root like that. That's fine. And we talked about how to clean up square roots. Try that a little bit and don't leave square roots in the denominator. But in this case, I got x equals 12. We're asking for cos theta and tan theta. Cosine of theta, now that I know all 3 sides, I just have to fill in the pieces. Cosine is my adjacent, which is 12, divided by my hypotenuse, which is 13. Done. Tangent of theta, if I go back to that SOHCAHTOA, TOA is O over A. It's going to be my opposite side, which is 5, divided by my adjacent side, which is 12. Can you do that stuff? Great. We're going to ask you a quiz for that sort of stuff next Wednesday. You got a bigger assignment today, and I know it's a little bit bigger. I'm giving you sort of till Monday. The idea is I don't have as much. I might put up another sort of like mini bonus quiz with some of these things that mixes it all together, but since it's 2 ratios, kind of think about it like 2 assignments jammed into one. I know it's a little bit longer, but some of these questions are going to fly. Try it. If we've got questions on this, please pop into office hours. You don't even have to really worry about what these problems are. This page 553, 5 through 10, 11, 13, 15, 17, 19, 24, 33, 35, 37, 39, 40, 43, and 49. Oh my goodness. Come here. Hey. Obi, come here. Get your iPad. Come here, buddy. Let's get on screen. You're going too wild right now. Wild, man. Okay. So, it's already on Clever, so you can just pop on and work through the questions. Those are the ones in the books if you're that concerned about it, but you don't necessarily need to be. As a reminder, the quiz question is going to ask you about what album am I excited about. Afterburner, one word. That's the album that I'm excited for. I hope you're staying safe, well, and healthy. Thank you, Obi. I know. They are very, very hungry dogs, and they're looking to go OUTSIDE. So with that, I wish you a good day. Again, every Wednesday, expect a quiz. I'll get the 9, what do we just do? 9-4 quizzes graded here pretty